Okay, we're going to talk about concentration and molarity today. This is notes part 5 from unit 6. Concentration is not your mind's ability to focus in chemistry. Concentration is how much stuff is in a certain amount of space. It's kind of like density, but for aqueous solutions. So what is a solution? A solution is a homogeneous mixture or homogeneous mixture. And that means it looks the same throughout. So you can't tell the parts by looking at the whole thing. It all looks like one substance, even though it's multiple substances mixed together. A solution is made of two parts: the solvent, which is the substance doing the dissolving. This would be something like water. Water is the universal solvent, meaning it can dissolve a large number of substances. The only ones it can't dissolve are nonpolar substances like oils and things like that. The solute is the substance being dissolved, so that's usually going to be a solid or another liquid or a gas being dissolved into the solution. If you mix sugar with water, sugar would be the solute, water would be the solvent. So we have solute plus solvent yields solution, meaning if I take a solid like this, that's the solute, I mix it with water, which is our solvent, together we get this, and this is some kind of copper-based compound in a solution. Saturated solutions are solutions that have the maximum amount of solute in it, and an unsaturated solution does not. So imagine trying to just dump tons of sugar into a cup of water. Eventually, you're going to hit a point where you can't get any more in there. There's not enough water to dissolve it. Then we would say it's saturated. Okay. The solution process is shown in this video. I'm just going to quickly share it with you here. Okay, that may have sounded like a fart, but that was my chair spinning as you're watching the video. That was it again. That was not me. That was the chair. This is in French and English for you French speakers. Now, this is salt being dissolved. So sodium ion, chloride ion. Remember, they have a positive and negative charge. And water is polar, which means it has partial positive and negative charges. So those water molecules come in. Notice the hydrogen, the red, the positive is facing the oxygen. I'm sorry, the chlorine in that salt and pulling it out of there. And consequently, if the oxygen gets near a sodium, it pulls it out of there and it separates those out. Okay. And that's how we get something like salt to dissolve. With sugar, sugar's polar, water's polar, so they attract and pull each other out. And this is what's going on at the particle level, at the molecular level, or ionic level in this case too. Okay, so let's talk about concentration. Concentration is the amount of solute dissolved in a given amount of solution. Remember, the solution is the whole thing. If I put a liter of water in a container and add salt to it, the volume is going to go above a liter because the salt has volume. So we're talking about in the solution. A dilute solution has a small amount of solute, meaning it doesn't have a lot. A concentrated solution has a large amount of solute. Remember, a saturated solution is at the max. Dilute and concentrated are relative terms. And here's what we mean by this. If I make my coffee, I like it what we would consider stronger or more concentrated. My wife prefers it to be a little bit lighter. And so, I taste her coffee and go, that's not very concentrated at all. And she's like, well, yeah, it is. So because those are relative terms, they have different meanings for different people. Chemistry has to have, a way to measure it with numbers and units. So let's consider this. Consider a Coca-Cola, and then ask yourself, what is the solvent? And then list 3 solutes in a Coke. So we're gonna, at this point, you'll be answering these questions, and then we'll move on. Let's look at some serving facts here. Here we have 80 proof vodka. I know you guys aren't 21 yet, so you don't really know what that is. It's an alcoholic beverage. Alcohol is 40%. I'm sorry, vodka is 40% alcohol. The other 60% is mostly water. Okay. If you look at wine, wine happens to be at 14%, which is quite a bit less. Again, the rest of it is mostly water. So, when you're drinking something like a beer when you're 21, if you drink a beer, it's 95% water. So these are all water-based solutions that we drink. Sodas when you're 21, alcoholic beverages possibly. All those things play a factor in there. We usually use percent in our everyday lives, but for chemistry, we use something that's a little easier to work with for us, and it's molarity. This allows us to express concentration quantitatively, meaning with numbers. Okay. So molarity is the number of moles of a solute in 1 liter of a solution. Remember, that's the solute and the solvent combined. So we have a way of solving these problems, and we have an equation for this as usual. And the molarity equation is the moles of solute divided by the liters of solution. When you see the symbol M with a number in front of it, we read it as molar. And we've talked about this in previous meetings, but I want to go into detail here. So 3.0 M would be read as 3.0 molar. Okay, if you were telling somebody what the concentration was. I also took the equation and put it into one of the triangle equations. So you could also work it using this thing if you need to help you figure out how to set that up. So if algebra is not your strong suit, use the triangle to get you going and figure out where everything should go when you set this thing up. Okay. So if the question asks for moles, for instance, I look at the triangle, I look at moles, and the other two guys are next to each other, which means moles equals molarity times liters. Okay. If I'm solving for liters, then it's going to be moles on top and molarity on the bottom, looking at this thing. Okay. And then again, if I'm looking for a molarity, it's going to be moles on top, liters on the bottom. So use the triangle at first if algebra is not your favorite, or you think you're not good at it. Use that first. Okay, so let's look at a practice problem here. We have a solution containing 2 moles of sodium chloride in 2 liters of solution, and it says what is the molarity. So let's go back real quick. This one's asking for a molarity, and the equation's already set up for that. So it's going to be moles over liters. So when I go to solve this thing, we're going to put it together like this. Molarity equals moles over liters. I plug in the numbers. It's 2 moles over 2 liters, which gives me an answer of 1 molar. Okay, 1.0 molar. And that is the concentration of that salt in that amount of water. Okay. Now, here's the thing with concentration. You have to really pay attention to this. If I have this in a jug and I've got like 10 liters of the stuff, all of that 10 liters has the concentration of 1 molar in this case. So if I pour some of it out, the concentration stays the same when you pour some out because it's a ratio of moles per liters. So if I have more liters, that means I also have more moles. Okay. It's like making a pot of coffee. It doesn't get less concentrated as I pour more out or more concentrated as I pour more out. All that coffee tastes the same if it's mixed properly. For number 2, it says how many moles of solute are in 2 liters of a 0.5 molar solution. So on this one, they're asking for moles. So using either the triangle or using some algebra, I can figure this question out pretty easily. So we start off with our equation, molarity equals moles per liter. We do some algebraic maneuvering. That liters is on the bottom, so it's going to go up there, which gives us molarity times liters. And then I plug in my numbers again, just as usual. Now, you got to remember 0.5 capital M really means moles per liter. So when I multiply, the liters cancel out and I get the answer I want. Okay, so you can really see how the units cancel on this. And in this case, for this answer, we'd get 1 mole. Okay, that's how many moles of solute are in there. Okay, let's look at CFU number 3. It says how many grams of NaF are in 0.2 liters of a 2 molar sodium fluoride solution. Okay, so now we're looking at grams. And so we have the need to get to grams, but the equation doesn't have grams in it. However, moles and grams are related to each other. Okay, so in that case, we're going to have to figure out how many moles of sodium fluoride, NaF, are in the solution first. Okay, so we do that with our molarity equation again. And again, when you're solving for moles, it's molarity times liters. If you do your algebra, we plug in the 2 molar, which is up there. We plug in the 2 liters, which is there. And we get 0.4 moles of sodium fluoride. Okay, well, the question's asking for grams, so we need to do that last conversion. So the 0.4 moles is coming from what we solved here. The 42 grams is coming from your best friend, the periodic table. And that's over 1 mole to get the units to cancel. And we get 16.8 grams of NaF, or 17. You can round it since everything has 2 sig. The lowest number of sig figs is 2 with the 2.0 and the 0.4. So you could round that to 17. If you left it like this, you'd still get it right if you were taking like an AP test next year or the year after. So that's that type of question when they ask for grams. Okay. Let's look at CFU number 4. It says you have 0.1 liter of solution, okay, with 10 grams of salt dissolved into the solution, sodium chloride. What is the concentration, which when you hear concentration, think molarity, of the solution? So in this one, I have grams, but it's asking for molarity. If I have grams, remember it's related to moles. So all I have to do is convert it. So the 10 grams goes on the top. The 58.5 grams is coming from the periodic table, adding up Na and Cl, their masses from there. And we get 0.171 moles of sodium chloride. Okay, so I pop that into the top there, and the 0.1 liter for the solution volume is on the bottom, and I divide, and we can see that this is a 1.71 molar sodium chloride solution in water. Okay, so we made salt water with that concentration. Okay. So that is about as tough as the calculations would get on a test for this stuff and on the homework assignments. And it's really just a matter of make sure you know that molarity equation. It would be given to you on a test. Make sure you understand the relationship between grams and moles. And you know the definitions of the parts of a solution and how they fit together, the solute, the solvent. Okay? And you guys will be good. What I'm going to show next is a demonstration of making a solution and calculating the molarity of that solution. And we're going to use sugar and water.